Good morning, everyone. Thank you for being here today. I'm excited to present our corrective maintenance fixing plan for AC units. On this first slide, you'll see the title and the focus of our discussion. Over the next few minutes, we'll explore the steps we're taking to ensure our air conditioning systems are operating efficiently and reliably. Let's get started. Today, I want to talk about our primary objective, which is to restore the normal operation of both packaged and split air conditioning units. Our focus is on addressing the most common issues that can cause these systems to fail or operate inefficiently. These include compressor faults, which are often at the heart of cooling problems, fan motor failures that can reduce airflow, and PCB or control issues that disrupt the system's ability to function properly. Additionally, refrigerant leaks are a critical concern because they can significantly impair cooling performance. By tackling these specific faults, we aim to ensure that these air conditioning units operate smoothly and reliably, ultimately providing comfort and efficiency for users. This objective ties directly into the overall goal of improving maintenance practices and system longevity across these types of AC units. Let's take a look at the equipment references listed here. For packaged units, we're using the Copeland Scroll Compressor ZR48KC TF7522. This type of compressor is known for its high efficiency and reliability, making it ideal for packaged systems where space and performance matter. On the other hand, for split units, we have the Copeland Hermetic Reciprocating Compressor CR47KQ TFD 280BM. Reciprocating compressors are often preferred in split systems because of their proven durability and ease of maintenance. These references are important because they help us identify the specific components used in our systems, ensuring we select the right equipment for the right application. Connecting this to our overall theme, understanding these details allows us to optimize system performance and maintenance, ultimately leading to better efficiency and longevity of the units. Let's take a closer look at the reported deficiencies. Starting with the packaged units, we have one unit that is leaking refrigerant and needs to be recharged with R22. Additionally, 4 other packaged units require new condenser fan motors, 3 of which also need new fan blades and refrigerant recharge. It's important to note that some compressors, like the grounded ZR48KC models, are also a concern. 3 units have these grounded compressors, and they also have refrigerant leaks that need addressing. Moving on to the split units, 3 of them need new condenser fan motors. Units in rooms 4 through 7 are in similar condition. They need fan motors, PCB boards, transformers, and refrigerant recharge with R22. This highlights a pattern of both mechanical and refrigerant issues across multiple units. Lastly, there's an office split unit with a defective CR47KQ compressor, which needs repair or replacement. The corridor unit also requires R22 recharge, and another split unit has a grounded compressor. These issues are critical because they directly impact the cooling efficiency and reliability of our systems. Overall, these deficiencies show us the ongoing challenges in maintaining optimal HVAC performance, and they underscore the importance of proactive maintenance and timely repairs to prevent bigger problems down the line. Let's go through the spare parts requirements specific to this model. First, we need 3 packaged compressors, specifically the ZR48KC TF7522 model, which we'll refer to as C1. Additionally, there are 2 split compressors, the CR47KQ TFD 280BM, labeled as C2. Moving on, for the condenser fan motors, we are looking at a range of 10 to 12 units, covering both packaged and split configurations. For the packaged units specifically, we need 5 fan blades to ensure proper airflow and cooling efficiency. In terms of electronic components, we require 3 PCB boards, which are for the split units, designated as B2. Along with that, there are 3 control transformers needed for these split units as well. Regarding refrigerants, we have a stock of 10 cylinders of R22 refrigerant, which is quite standard. If there are any packaged retrofit units in place, We should also have 4 cylinders of R410 refrigerant available. For maintenance and testing, nitrogen gas is essential, and we need 2 cylinders on hand. Additionally, a complete welding set, including acetylene and oxygen, is necessary for any on-site repairs or adjustments. To connect this to our overall maintenance and operational planning, ensuring we have these spare parts ready will help us minimize downtime and keep the system running smoothly. This list highlights the key components that are most likely to need replacement or servicing, so proper inventory management is vital. Let's walk through the key steps involved in corrective maintenance for these units. When replacing a compressor, the process varies slightly depending on the type of unit. For packaged units, like the ZR48KC scroll, we start by isolating the system, then recovering the gas to ensure safety and prevent any leaks. Next, we replace the compressor, perform a leak test to confirm there's no leakage, and then evacuate the system with a vacuum. After that, we recharge it with refrigerant and monitor the system to ensure it's operating correctly. For split units, such as the CR47KQ reciprocating, the steps are quite similar. Isolate, recover, replace the compressor, leak test, vacuum, recharge, and monitor. The main difference is the type of compressor, but the overall process remains consistent to guarantee reliable operation. Moving on to fan motors and blades, the key points are to replace the faulty motors or blades, then carefully align the rotation to prevent vibration or imbalance. Balancing the blades afterward is essential to ensure smooth operation and reduce wear on the system. When it comes to PCBs and transformers, especially in split units like the IDC-B2, we focus on replacing any defective PCB boards and transformers. After replacement, reprogramming the control boards is crucial to restore the proper operation of the unit. Lastly, for refrigerant leaks and welding work, we first repair leaks using nitrogen purge to keep the system clean and prevent contamination during welding. Once the leak is fixed, we recharge the refrigerant to the correct levels, ensuring the system operates efficiently. All these steps are interconnected, highlighting the importance of thoroughness in corrective maintenance to keep our HVAC systems running smoothly and efficiently. Let's talk about testing and commissioning. This phase is absolutely critical to ensure that everything we've installed functions correctly and safely before the project is handed over. During testing, we systematically check each component and system to verify that they meet the specified requirements. It's like giving the entire setup a thorough health check. Commissioning, on the other hand, is about fine-tuning and making sure all systems work together seamlessly in the real-world environment. We conduct operational tests, troubleshoot any issues, and adjust settings as needed. This process not only confirms that the project is ready, but also helps us identify and resolve potential problems early, saving time and costs down the line. Overall, testing and commissioning are the final steps that assure quality, safety, and performance. They are essential for delivering a reliable and efficient system that fulfills the project's goals and our clients' expectations. Let's take a closer look at the bill of quantities for this project. Starting with the compressors, we have 3 packaged units, specifically the Copeland Scroll ZR48KC TF7522 model. These are essential for the packaged systems, and we'll need 3 of them. For the split units, we're using 2 Copeland hermetic compressors, model CR47KQ TFD 280BM. These 2 will handle the split configurations. Moving on to the condenser fan motors, we will require between 10 to 12 units. These are vital for both packaged and split systems, ensuring proper heat dissipation. Additionally, there are 5 fan blades designated for the packaged units, which helps in maintaining airflow and efficiency. For the control and electronic components, we need 3 PCB boards and 3 control transformers, both specifically for the split units. These components are crucial for the control systems and proper operation of the split systems. Regarding refrigerants, we're using refrigerant R22, with 10 cylinders available for recharging in case of leaks, and 4 cylinders of R410 for retrofitting the packaged units. It's important to note the different refrigerants and their roles in system efficiency and environmental considerations. We also have 2 cylinders of nitrogen gas, which will be used for leak testing and purging the systems to ensure there are no leaks before commissioning. Lastly, there's a complete welding set with acetylene and oxygen, which is necessary for leak repairs and brazing work during installation and maintenance. Overall, this BOQ provides a comprehensive overview of the key materials and components needed to successfully complete the HVAC system upgrades, ensuring we have everything covered for quality, efficiency, and reliability.